Well, it's surprising to know that solar storms begin at the sun for some people. But sometimes the storm may begin at the surface of the sun or at the very corona or the outside bubble of the sun or the atmosphere of the sun. The magnetosphere, the ionosphere, and the atmosphere have all different integrities. And sometimes when you get a solar coronal mass ejection, the energy is being released from the actual outer corona of the sun, not from the actual surface of the sun. But a solar flare, its origin, its begins at the very surface of the sun, because it's an emission and an eruption of plasmatic energy by the trillions. What's really happening there, specifically with solar flares, is better understood if you read on the process of making helium. The sun makes helium from helium with has four, I think, if I'm not mistaken, four proton or electron outer shell. I'm not familiar with that, but it makes helium at the rate at which it makes helium when it is disturbed, or its cycle is perturbed or hindered or deviated for whatever reasons, and maybe you suffer a phenomenon or an anomaly. It releases a solar flare of energy, and sometimes that energy escapes the sun, or the gravitational pull, the strong gravitational pull of the sun brings it back down into the sun. And sometimes a dark spot can form on the sun because of it. And sometimes the sun, at its 11th year cycle, sometimes the sun will emit a great number of solar flares. Not that it would reach the earth, but some do. But that is a great deal of electroplasmatic activity on a radiation from solar radiation. Now, the gravitational radiation of the sun is completely different in the sense that its intensity is exponentially by far more powerful than the planets combined. We would understand that. But to better understand, a CME is a coronal mass ejection. And the coronal mass ejection is emitted from the corona of the sun, which is much hotter than we think. But when the light of the sun travels at millions and millions and millions of miles per hour toward the Earth, the actual Earth's electromagnetic shield blocks the rays from the sun. Not all of the rays, but it reflects it, it repels it. On the very outer surface of the electromagnetic shield of the Earth, the very surface of it, its topographical surface has multiple ridges, and upon these ridges, they have cracks and crevices. Not that the lights pass through or the heat passes through the cracks and crevices, but the cracks and crevices allow for energy of the sun to be dispensated or dispersed, permitting a cooling effect. And not too many people know that. And as far as solar, EMPs, electromagnetic pulses, we get that from the sun in multiple forms, not just in one form, but many forms. We get microwave energy from the sun also. We get X-ray energy from the sun, ultraviolet rays, and the spectrum from the rainbow. You get all those lights. The disposition of the Earth. Now, the relationship of the Earth and the sun is very important. If the Earth, let's just say, for example, if there's a great deal of activity on the sun, you have to ask yourself, well, will this activity affect the Earth's inner integrity? Or let's just say the Earth's core. Will it create a volcanic eruption, or can it alter weather, drastically alter weather, or can it create a natural disaster? And the answer to that is a resounding yes, of course. It can create a natural disaster. And it hasn't been until recently that NASA is able to predict solar mass ejections up to the third and fourth hour before released. That's what they're claiming. They don't have a real model to prove it, a mathematical model or algorithmic model or any type of model that's three-dimensional, four-dimensional, that can actually be applicable to predicting solar flare catastrophes or geomagnetic storms. We have to take consideration that gravity in itself has a nature, a behavior all on its own. Sometimes we mistake into geomagnetic storm from solar magnetic energy, and they're not the same. Geomagnetic storm is actually the result of the solar, the solar energy, being dispensated upon the ridges of the outer shield of the Earth. I mentioned the ridges again because it's not really mentioned much in the heliophysics portion or heliophysics part in study of the scientific part of the website of NASA. NASA is very young and new to heliophysics physical studies. They have the SDO. There's a solar dynamic observatory that's out there. And in 2019 or 2018, they'll be launching the Webb, WEBB, James Webb Telescope. And I think the mirror that will be absorbing the light energies from stars billions and billions of miles away, the mirror I think will be 6.8 meters in height. And I think that comes out to something roughly close to 19 to 23 feet in diameter. The mirror will be, when they launch the Webb, the mirror will be folded within the solar array panels, the solar array with an A, array panels, and it would unfold and it would deploy along with the solar array panels. But the mirror will, I guess, assemble from a disassembled disposition into a fully formed functioning mirror. Now, I find that very fascinating. They will be able to see other worlds besides, I'm sure, near Earth. They have discovered, I think there are roughly close to, if not more than 20 Earth-like planets with surface temperatures ranging anywhere between 60 and 90 degrees. And they're not too sure whether or not the surface of the planets are inhabitable. They don't know if it's a class M3 planet. Class M3 planet means a planet is able to sustain life. But they know that the majority of the planets that are near life have a rich nitrogen atmosphere. That means that it's ambient in temperature. And rich nitrogen means that the ambient in temperatures mean that the higher levels of the stratosphere is cold, and that the surface temperature, if the surface temperatures are warm, so that you might very well likely have a rain. These things I find to be interesting for me. It's just interesting. I don't find it to be too challenging. I don't mean to sound too obnoxious or too crude, but I don't find it too challenging. I think that we should be far more advanced than that. Very much far more advanced than that. I think that we should be already understanding the behavior of the sun. We should be able to predict the rates at which helium is being processed, and by the rate in which it emits the amount of hydrogens as byproducts. We should be able to predetermine solar storms or 11-year cycles, and actually see whether or not the solar energies that are emitted that are dangerous to the sun, to the earth, energies that are emitted that are dangerous to the earth. We should be able to locate these specific regions of the earth that these energies would strike and be prepared, very well prepared, but we haven't even begun to strike the surface. I remember long ago, this is in 2008, when I was doing a great deal of research at the time, when it was during writing the volume 1 of Plasma Phase Physics. I was very well endowed and very well, how to say, involved with NASA scientists. I have the emails to prove it, but I won't reveal them. I have the emails to prove my engagement with NOAA scientists, NASA, CDC, which is the Center for Disease Control, WHO, which is World Health Organizations, OEM, FEMA, all the natural disaster first responders. And I've created a great deal of argument, and I've asked them why aren't they, how to say, integrated? Why aren't their websites integrated? Why aren't their bureaucracies integrated? And why is it that CDC at the time was, why is CDC considered the matrix or the mainframe or the go-to or the go-for when it comes down to disease studies and how to say vaccine replication, or just why is the CDC the center, the nucleus for diseases? And my argument was that shouldn't the World Health Organization be designed in such a way that they are leading the global expedition. The mission objective should be that the World Health Organization should be leading the interest of diseases and prevention, disease prevention. To put it simply, it was more like my argument was, why don't you have a prediction model for disease outbreaks? And the CDC said, well, we don't have the anomaly, we don't have the mathematics, we don't have. I said to them, then why don't you know where the origin? How come you can't predetermine where the origins are at, or predetermine where the origins of disease outbreaks will be? I said, oh, because we just don't know. I said, well, then you shouldn't be leading. The World Health Organization should be leading global affairs, these global mission interests. And later down the line, after a great deal of deliberation and challenging them and making statements that they don't have a natural disaster prediction prevention protocol, and that the President of the United States should have a priority one objective to create policy, they felt that, well, maybe we should integrate. And I guess they later down the line they did integrate. They had the CDC run the bureaucratical infrastructure of the World Health Organization. And it was okay until the Ebola outbreak happened again, and they were unprepared. And some of you might wonder, oh, well, what does this have anything to do with, the disposition of the Earth in relationship with the Sun? Have anything to do with the behaviorism of disease outbreak? Well, there you have it. There's a code there. There's a behaviorism that needs to be studied. And if you read plasma phase physics, you'll find in chapter, if I'm not mistaken, chapter 24 or chapter 23, you'll find that very, very topic being discussed in depth, and exactly what the CDC and the WHO could be doing to create prediction models for disease outbreaks. And again, I discussed in this book a great deal about natural disasters having to do with hurricanes, volcanoes, eruptions, earthquakes, tsunamis, cyclones, tornadoes, typhoons, breach of anomalies in the atmosphere. I've done a great deal of research on these particular interests, and I raised these questions. I raised a great deal of questions to the leading agencies of the Earth, believe it or not. Hold on one second. And yes, the USGS, I don't know if anyone here is familiar with the USGS. It's the United States Geological Survey Institute organization. And it's responsible for seismology readings. They have sites, I would say, or small monitoring stations all over the globe, actually. You'll be amazed. They have close to 1 million, I think, or even more. That actually sensed deviations from the Earth's mantle, or deviations in the Earth crusts, or the slips of faults, and what have you. And that's very important to understand, because a lot of people are asking, especially in Nepal and just recently in Ecuador, what could have been done to have predicted or prevented, the loss of property, land, and of course life. And in my opinion, I think there could have been a lot done, especially in Japan, that is equipped with the technology to predict, prevent, and intervene in such earthquakes, even in remote areas. Generally, the system is designed in such a way that you'll find only that if you have interest in presenting or submitting ideas, especially as a citizen scientist, that you would have to submit them in a certain manner. And generally, a certain manner would mean that you would have to be either an operating entity. Citizen scientists would have to submit their ideas, but have to be cautious about the intellectual properties. They would have to fill out some PDFs or white papers and file specific formats. There's a great deal to understand about the relationship of the Earth and the Sun, and how we react on a political level to deviant behavior of our Senate, of our Republican and Democratic parties toward responding toward dealing with natural disasters. And I've spoken to a lot of savvy physicists and students and scientists and doctors and friends and colleagues and your laymen, janitors, plumbers, have common, just common core conversations. And I asked them, wouldn't it be great that FEMA, which is FEMA, OSHA, OEM, the Office of Emergency Management, the Homeland Security, I would just say the engineers of the Army, our Army Corps of Engineers, to name a few, we have the Coast Guard, Chief of the Coast Guards, all of which I've spoken with and written to in regards to natural disasters, should be in one particular, collaboration or integration of some specific language that they can all understand, and have real-time data accessible to them so that they can respond in a more, vibrant and effective way to save life. Instead of just giving evacuation, warnings, they should be able to have a specific system in place where they can actually evacuate people. Not just leave the area and you're on your own, and the majority of the masses of the populations, because of this type of reactionary behavior, might evacuate a specific region, let's just say a region 4, and head up north by northeast into region 9 and find themselves in another catastrophe. You see? And if region 9 and region 4 need to be evacuated, these are codes, by the way, that governments use here in the United States to name and identify specific states when it comes down to levels of priority. And region 2 would be New York, and region 3 would be, let's just say, Ohio. Region 4 would be, let's just say, not Montreal, but Maine. And region 9 may be Florida. So a great deal of people might be leaving one particular natural disaster ahead, but be leading themselves into another. So instead of having people just flee, or evacuate specific region, they should create safe zones and with protective housing and ample food and water supplies. They should be personally and directly involved with leading the people out. But I find this to be peculiar, that's all. And I question these things, and that's why I write about them. I challenge the greed of politics, the sociological machine and the interest of their psychodemographics in studying people's behaviors, and the purposeful natures of artificial intelligence. What purpose does technology serve, if not the betterment of the human development? I really invite you guys to share the book. I mean, when you get a chance, go on Barnes and Nobles, or if you're anywhere on Earth that you might be, whether you're in Russia, Estonia, China, or if you're in Italy, France, Germany, Spain, Japan, Korea. It doesn't matter where you are. The book is online and it's accessible. If you'd like to purchase it and read it. It has an index, a table of contents, and an index and a variable glossary, and and a bit about me, about the author. I just welcome you guys to Plasma Phase Physics, discussions, and I think I'll be holding a bit more. These discussions and periscopes are not about me; they're about you, and about the safety of people, land, and property. So that it's not it's not by who I am, but by what I do that you will know me. So if you really want to get to know me, forget about what I look like. Be more concerned about what's written and really get yourself involved in upgrading your knowledge, becoming endowed, and and bequeathed with higher levels of information, because the information that are in our government websites are not being accessed by the multitudes, but by the few. And we have a few students they're gearing toward educational for bad terms, educationalizing children, or teaching children or informing children about the sciences of the future. But I've studied the websites and the way they have changed and altered them. They're horrible. In my perspective, and in my opinion, they're horrible, because they're actionable data. It's not real time. It's not applicable. It's not usable as it used to be. I used to be able to open up the NASA website and find the very speed of the electromagnetosphere of the Earth, the rate of speed, and the wind speed of the sun. I used to do mathematical models just with that alone to predetermine within months and months and months in advance, weathers to come. I used to follow proton energy that used to be released from the sun and locate exactly where on the atmosphere or the stratosphere that the proton energy had been emitted from the sun onto the Earth's surface. And I used to time the amount of time, the longevity of the amount of energy. To say the proton energy was over Minnesota for, 10 hours. And then I would make a predeterminate mathematical model, a predeterminate model that within that 10 hour, because of that 10 hour, proton energy emission, anywhere between the following third and fourth hour, there would be a natural catastrophe. And lo and behold, there were a great deal of natural catastrophes within specific regions of the Midwest after that particular proton energy emission. However, although there weren't X-ray flares, there were solar flares that had a great deal of proton energy in them. Anyway, I'm going to close here. I appreciate your visitation. I invite you guys to come and visit some more, and maybe we'll get a little more deeper into certain subjects that I will be discussing about sometime in the future. Anyway, if you haven't bought the book, buy it, get it now, read it, and become informed. Thanks for visiting, and share and like and follow. You can follow Plasma Faith Physics via Twitter at Plasma Faith Phys without the X, ICS, and you can follow me on Periscope. I would appreciate it. You have a great day.